Hey everyone, welcome back to our TxePrep video. And in this video, we're going to solve problem number 4 from the 2015 AIME 2. And this problem is basically a geometry problem with logarithms in it. So it says that in an isosceles trapezoid, the parallel bases have length log 3 and log 192. The altitude between the bases is log 16, and the perimeter can be written as log of 2p times 3q, and we're asked to find p plus q. This time MAA, Mathematical Association of America, is not using m and n as the dummy variables here. But that's besides the point. So the first thing I like to do with every geometry problem is simply just draw a diagram. So we're going to draw an isosceles trapezoid. It's going to look something like this. And it may not be exactly to scale, it doesn't matter, because we're just using numerical values here. So we see that the bases are log 3 and log 192. So the smaller base must be log 3 and the larger base must be log 192. So that's exactly what we're going to do. And the altitude is going to be log 16. So I'm going to draw an altitude over here, and I'm going to call this log 16. And now I'm going to label the points. So I'm going to call this AB, and I'm going to call this CD, and then I'm going to call the intersection over here E. And what we want to do is find the perimeter of this trapezoid. And in order to do that, we need to find the lengths of AD and BC. And we know that these are both the same since the trapezoid is isosceles. So we can call this y, and we can call that also y. But in order to solve for y, we need to find the distance between D and E, because that's how we can use the Pythagorean theorem to help us solve for y. And one more side note is that this triangle over here is also the same as AED, which is the same as B. I'll call this point over here FC. And that means this FC must also be X. And DE, I'm also going to call X to represent this length over here. And then we make one key note. We notice one key thing. Log 192 minus 2x is going to be log 3. So we can write this like log 192 minus 2x is equal to log 3. And after rearranging both terms, what we get is log 192 minus log 3 is equal to 2x. And now we can use the log properties over here to divide 192 by 3. And that's going to leave us with log of 64 is equal to 2x. And now we divide both sides by 2. And that leaves us with log 64 over 2 is equal to x. And what we notice from that is we have a fraction over here. And whenever we have a constant be multiplied by a logarithm, the constant can simply be represented as the exponent of the inside part of the logarithm, which is simply one of the log rules. So since this constant over here is 1/2, well, the square root of 64 is simply just 8. So that means x is equal to log 8. Okay, that simplifies things a lot easier because all I have to do now is just use the Pythagorean theorem to help us find y. So I'm going to replace log 8 over here, and I'm going to call this log 16 as well. And now we just have to find y. And we can use the Pythagorean theorem for that. So that's exactly what we're going to do. So log 16 squared plus log 8 squared is equal to y squared. But we immediately run into a problem over here. And the problem is log 16 squared and log 8 squared aren't exactly like terms, so they can't really be combined or simplified. But we have one thing we can do. We can represent these both, log 16 and log 8, as something times log base 2. And let me show you what I mean. So let's say, let me just pull an arrow out here. We can say that log 16 is going to be the same thing as 4 log 2. And this is going to be the same logic that I applied to this property over here, since we have a constant and we can just do log, and this is going to be the same thing as log of 2 to the power of 4, which is 16. And we can apply the same thing for log base 8. So this is going to be log base 8, which is equal to 3 log 2, which is 2 to the power of 3 and 8, so that confirms out. So now let's just rewrite this over here. This is going to be 4 log 2 all squared plus 3 log 2 all squared, and that's equal to y squared. And now we can just square both terms and then simplify. So this is going to be 16, and then in parentheses log 2 squared plus 9 in parentheses log 2 squared, and that's all equal to y squared. And we notice that the log 2 squared is a common term, so we can just simplify this into 25 log 2 squared, and that's equal to y squared, meaning that y must equal to the square root. We take the square root on both sides, and this must be 5 log 2. And remember, we want to represent it as a single logarithm over here, so it's best to just get rid of the 5, and in order to do that, we can just do log of 2 to the power of 5, which is simply just equal to log base 32. Okay, so now we've gotten done with all of the, we've found every single value that needs to be found, and we can just replace the y's over here with log 32, and same over here. And now we're just going to combine it all to find log 2 to the p and 3 to the q. So that's going to be the same. We're just going to add up all of the terms over here. So that's going to be log 32 plus log 32 plus log 192 plus log 3. And when we add this all up, it becomes a single logarithm, again because of logarithm rules. So that's going to be the same thing as log of 32 times 32 times 192 times 3. And we can just find the prime factorizations of each and then simplify it. So this will be log of 2 to the 5th times 2 to the 5th times 2 to the 6th times 3 times 3. And we can combine these again to make this log of 5 plus 5 plus 6 is 16, so 2 to the 16, and 1 plus 1 is just 3 squared. And we already have it in the form log of 2 to the p and times 3 to the q. And in this case, p is equal to 16 and q is equal to 2, which must mean that p plus q is going to be 18, which is our final answer to this problem over here.